Hello, Workplace Math 10 students. Hope everything's going well with you. This is another video to explain the 6.4 similar triangles assignment that has been posted on your Google Classroom. So let's just take a look at that assignment first of all. So what we see here is that you have an assignment in here that says 6.4 similar triangles, and your screen is going to look a little different than mine, but basically when you come in here, you're going to have a worksheet itself that you can click on, as well as some instructions which I'm going to use in this video to guide you through and explain 3 of the questions. Now, one of the things you want to be aware of is that once you have printed off the worksheet, or if you don't have a functional printer at your home, if you even simply just do on pen and paper or pencil and paper the worksheet questions, then what you want to do is take a picture of those completed worksheet or assignment, and then you want to upload this onto your Google Classroom. And what you'll see is, and it's a little different on your screen, you're going to see up at the top here a submit option button, and in there you're going to also have an option to upload pictures, and so that's where you would do that and submit it to me so that I'm aware of what it is you've completed. So moving forward though, if we click on the 6.4 worksheet, we're going to see that this worksheet requires you to do 10 questions. And these questions are all a little bit different, but I've tried to pick 3 of it, what I would say are the harder of the questions. We're going to go over those together in this video to make sure you understand how to do this. So let's take a look at this. So the very first thing I want to do is I want to just review what we've already learned about similar figures. Once again, similar figures have the same shape but different sizes. And once again, the angles of each particular similar figure are equal. And lastly, we know that the corresponding sides of similar figures are not the same, because otherwise it would be the same size, but they are proportional. And once again, this concept is what allows us to find out missing side lengths on shapes. So let's take a look at question 3 here. So what we see here is we see that we have 2 triangles here. We have a triangle DEC and we have a triangle ABC. Now this diagram suggests that these triangles are essentially equivalent in size, but in reality the numbers we have here suggest far different. What we see here is that triangle DEC is much smaller, and that the smallest side of triangle DEC is 50. We also see then that the smallest side of triangle ABC is 175. Now how we know that is that we are given 3 numbers here, and the number 175 is the smallest of these 3 side lengths for this triangle, so obviously it is the smallest side. Now what we also are given is the longest side of ABC, because obviously the largest of these 3 numbers is 210, but what we don't know is the longest side of triangle DEC. So what we want to do though is we want to take these 2 values that we have, 50 and 175, that we know correspond with each other, and we want to put it into a fraction just like we've done here, 50 over 175. Now could we have put it 175 over 50? Absolutely. But if we did it that way, then we'd have to flip these 2 values over here as well. So the way we have set it up here with the smaller triangle corresponding value on top and the larger triangle corresponding value at the bottom, we now then need to have what we're looking for, which is the longest side of the small triangle at the top here, and the longest side of the large triangle at the bottom. Now at this point, when we have it set up this way, it is very simple to solve. We simply need to cross multiply by this value here, and then divide by what's left over. So when we plug 50 times 210 into the calculator, we're going to come up with a value of 10,500. Now what we need to do then is then the leftover number, 175, we need to divide both sides, or in this case, this number, 10,500, by 175. So we are going to divide this by 175. So if I were to plug into my calculator 10,500 divided by 175, what I'm going to end up with is a value of 60. So therefore, DEC, the longest side of DEC, is 60. And this makes sense because it is the longest side, and therefore it should be longer than the other side that we have given for DEC. So that all makes sense. So let's take a look now at another question, but before I do that, I'm just going to clear off my annotations here so that the next section is going to be easier to view. That's my dog barking in the background. And so we now then have question 5 that we're looking at here. Now this is a little bit different question in that we are now looking at a triangle, two triangles, and both triangles share one common point, which is point A. So what we see is we have a triangle ABC, and that triangle is smaller than triangle ADE. And what we are told here is that the side length AB is 80, and we are told that the side length AD of the bigger triangle is 123. We are also told that the length of AE is 145, but what we don't know is the shorter, smaller triangle length of AC. So given this, what we do know is that these two side lengths correspond with each other, so we can set this up over here as 80 over 123. And then once again, what we're looking for is the smaller triangle length, so we put that unknown value at the top to match with the smaller side length here. So once again, what we're going to be doing is we're going to cross multiply by the two numbers we have, which is 80 times 145, and that's going to arrive as a value of 11,600 when we multiply that into our calculator, 80 times 145. We're then going to divide by the leftover number, 123, and what we're going to end up with is a bit of a decimal value. So when we take 11,600 and divide it by 123, what we're going to end up with is a value of 94.308 something or other. So I just rounded it to 94.31. So what we're saying here, just so we understand this, is that we were saying that the side length of AB is 80, and that the collective side length of this whole thing here was 123. We then were told that the side length of this whole collective A to E was 145. And so we would expect, because 145 is bigger than 123, that with the corresponding side length of the smaller triangle, that this number should be larger, which in fact it is. It's 94.31. So hopefully that makes sense to you. So I'm just going to erase this off now, and we'll move on to the final question. So this final question is question 10, and there's a couple of reasons I chose to use this one. The first reason was because it's kind of missing the last part of the question. And secondly, because it is a little bit challenging because it's adding in the concept of perimeter. So basically the actual question, which is never actually asked here, is what is the perimeter of the larger triangle that we're looking at? So what we see here is we have two triangles, triangle ABC, which is smaller than triangle FED. And notice that I have written these in order, so just a reminder again, if I write that we have triangle ABC, then A and F angles correspond with each other. Likewise, B and E angles correspond with each other, and angles C and D correspond with each other. So it's very important the way we write the order of these triangles. Now, what we see as well is when we talk about perimeter, perimeter is simply the full length around the entire figure. So when we talk about the perimeter of the smaller triangle ABC, and it tells us that it's 183, then what we're saying is the collective length of side AB, BC, and CA all added together is 183. That's what perimeter means. Now, we are also told in this question that one of the side lengths of triangle ABC is 67. So 67 is one of the side lengths that collectively add up to 183 in triangle ABC. But what we're also told is that this 67 corresponds with the larger triangle FED, and that one side length in FED is 335. Now, if the one side length of FED is 335, we'd expect the perimeter to be substantially larger than that because it would be all three of these side lengths added together. So what we need to do then is we know that 67 and 335 correspond with each other. That's what it tells us here. So we're going to put that into our fraction, 67 divided by, over 335. And then likewise here, because the 67 relates to the smaller triangle, I'm going to put the full perimeter value of that smaller triangle up top here. And then what I'm searching for is the perimeter of the larger triangle. So at this point here, we are going to need to cross multiply by the two values we have. So 335 times 183 is going to produce a large value, which is 61,305. We then need to divide by the value that is left over, which is 67. And when we do that, 61,305 divided by 67 is going to give us a value of 915. And this makes sense because, first of all, this 915 should be bigger, much bigger, than the one side length of that triangle. So this is bigger than 335. And it also makes sense because this value should be substantially bigger than the smaller triangle as well. So this makes sense. It is correct. Hopefully this all is clear to you now. And once again, I would encourage you to either print off that worksheet or to do it on pencil and paper. But once you finish the worksheet, please make sure you take photos of it and then submit it within this assignment itself so that I can grade it. Thanks for watching.